Hello, hello, hello. Hello, students. Nice to see you back again. And today we are going to be finishing up our notes on living things. So if you haven't done so already, open up those notebooks to our lesson notes for living things. And if you recall, yesterday we left off with the 6 characteristics of living things. So take a moment right now and just go down the list and make sure your notes are complete. All living things, and remember, these are the characteristics of living things on planet Earth as we are aware of them so far. All living things are made of cells. They all have the ability to move. They all undergo chemical activities. By the way, does anyone remember what one word can summarize all of those chemical activities? Metabolism is correct. All living things grow and develop. All living things respond to a stimulus. And finally, all living things must reproduce. So these are the 6 characteristics of all living things as we are aware on planet Earth. So let's begin with, for today, let's continue in our notes and begin talking about the origins of life. Some of you might be thinking about, okay, now we know the characteristics of living things. We know what a living thing is. We know examples of living things. Here's a picture of a living thing. Well, a picture of a living thing, not an actual living thing, a housefly. But where'd they come from? The origins of these living things here on Earth. Well, we're going to take a little walk through history because there was a time when people had a different idea of the origins of living things. So, as we look at this picture here, some of you might be scratching your head and saying, "Well, what does a fly and a slab of meat have to do with this discussion of the origin of life?" Well, let's talk about a theory. It's called the spontaneous generation theory. Spontaneous generation theory. Raise your hand if you have any idea what the word spontaneous means. Maybe some of you are spontaneous people. What does it mean to be spontaneous? Well, in this context, spontaneous means all of a sudden, out of nowhere, boom, bang. Spontaneous, all of a sudden. Generation. The word generation here has to do with living things, passing the torch, so to speak, to other living things. So from one generation to another. So generations coming, boom, all of a sudden. And the theory is an idea, basically an idea that some folks have had over the years. So let's talk about the spontaneous generation theory. And we can describe the spontaneous generation theory as being explained as that living things come from non-living matter all by itself. So imagine for a moment a rotting piece of flesh, a piece of meat just laying there, and flies spontaneously being generated by that non-living piece of matter. That's what the spontaneous generation theory suggests, that living things, life, comes from non-living things all by itself. Poof, bang, bam, all by itself. the spontaneous generation theory. We'll get back to this thought, this concept, this idea a number of times throughout the year, but does that make sense to you? Do you think that flies come from rotting flesh? If you do, I'm not judging you for that, because people used to believe that for many, many years, until someone by the name of Francesco, not Francesco Rinaldi, I think that's a tomato sauce dude, but Francesco Redi, who also was Italian, by the way, in the year 1668. He performed a very famous experiment which actually disproved the theory of spontaneous generation with a very simple experiment using meat and flies. Now, I do want to give you a little context here and defend the folks that believe this in the historical context in which they believed it. Here's the deal. I'm going to oversimplify it just so that you get the idea. Imagine living in a world where there were no garbage collectors. What would you do with your trash? You'd probably want to get rid of it out of your house and throw it out into the street, perhaps. Well, if there wasn't garbage collection, what do you think would happen to that garbage? It would just sit there and start rotting. Well, in many towns back in the old days, to keep these piles kind of limited, they'd have like a garbage dump, a public garbage dump where everybody would throw their garbage out of their house and just bring it to the neighborhood pile and throw it on the heat. Now, they'd throw everything there. Imagine all of the stuff within the course of a week that you throw out from your house, all the leftovers, all the crumpled papers, anything that you consider trash or garbage, you throw out. Garbage collection takes it and they bring it to probably a landfill or an incinerator. And they either burn it and make electricity with it, like we have in Warren County, or they put it in a landfill, which we also have in Warren County. And they just pile the garbage over and over, and then eventually they cap it or fill it over with soil, and it becomes a little mound in the landscape, actually a pretty big mound in the landscape. Either way, garbage is being brought somewhere. Well, what happens to that garbage if it's not burned up? Well, it decays, it decomposes, and it can attract vermin. Vermin is a nice term and an inclusive term for mice, rats, flies, and various other critters that would be attracted to all of the rotting and decomposing icky stuff that the town is throwing out. Now imagine you're a townsperson starting off as a kid. Maybe you'd go and play on that big mound. Maybe it was the highest elevation in town. So you'd climb up to the top of this pile of garbage and you'd see all of this rotting stuff like rotting meat. And maybe you were curious and you'd watch it and you'd see, looking down in this rotting piece of meat that was last week's dinner, and out of it, you see flies emerging. And you're like making the logical connection. Well, I guess that's where flies come from. We have so many of them in town, and here they're coming out of this dead meat. That must be where flies come from. So maybe you ask Mom and Dad, Mom, Dad, where do flies come from? And when they were your age, they made the same observation. Well, little kid, they come from that dead meat. And so you would grow up believing that dead flies come from dead meat. Well, you pass that knowledge down from one generation to another. Why would you question it? Flies come from dead meat. Well, while you're on top of this pile, you see big rats coming out from underneath the pile. And again, you might make the logical connection. Boy, all these rats we have running around our town, They must come from the big pile of rotting trash. So when you ask Mom and Dad, where do these rats come from? They might tell you, well, Junior, they come from that big pile of rotting trash down the street. And so you might grow up believing that rats, mice, flies, and all those other vermin come from that pile. Well, that's what people believed for a long time. Until Francesco Redi, who was a rather astute individual in Italy at the time, said, you know what, I don't think that's where living things come from. They just don't spontaneously generate themselves from non-living stuff in a trash heap. He had a different hypothesis. And so he did this famous experiment called the famous Redi experiment, where he had 3 jars. One jar with that was open and a piece of rotting meat. A second jar with rotting meat in it, but with cheesecloth, like a fabric on top of the jar. And a third jar with rotting meat, but with a lid on the top of the jar. And what I'd like to do right now is to try to replicate Redi's experiment by using my trained fly Freddy. And so let's go over to our close-up lab here, and we're replicating Redi's famous experiment. Here we have an open jar with a simulated piece of raw meat in it, a second jar with the rotting meat in it, but with a paper towel over top, and a third jar with a lid, also with the rotting meat. So we've got 3 jars, all the same kind of jar. We've got rotting meat, all the same kind of meat. The only variable, the only thing that's different from one to another is one is open, one has a cloth, and one has a lid. So let me go over and start training my trained fly Freddy here, and he's going to take off. There he is. Here's Freddy buzzing around. Buzz. Let's see what Freddy does. Which one of these jars is he going to be attracted to first? Well, oh, look at that. Oh, he's landing on the first jar. Now he's diving in. Oh, yeah. He's chowing down on that yummy meat. Now, why do you think he went to that jar first? Why do you think? Yeah, it's the jar he could get to. Not only could he smell it, but he was able to get into that. Oh, he could get into that jar. Now I'm watching him. Oh, it looks like Freddy's not really a Freddy. Maybe Freddy is a Francine, because I notice the fly laying eggs, laying little white specks all over that meat. In addition to eating, she's also laying eggs. Oh, looks like she's done. So Freddy or Francine, whoever you choose to be here, let's see what else Freddy does. Whoa. Oh, looks like the fly is landing on the jar with the paper towel. Now, Freddy can't get in because the paper towel's in the way, but it looks like Freddy can smell all of that yummy food. Oh, wait. I see little dots. They look like little white eggs coming out of Freddy or Francine on top of the paper towel. And oop, she's done. And now, let's see what else Freddy does. Doesn't even bother with the third jar. And now Freddy Freddy's just like flying away. Oh, I think Freddy is interested in the camera there. I don't know, Freddy. What do you think about these people watching you? Woo! All right, say goodbye, Freddy. Time to leave. All right, Freddy is leaving now. And so let's check out these 3 jars. The open jar, the jar with the cloth, and the jar with the lid. Well, if we allow time to pass, tick tock, tick tock, tick tock, time is passing. Over time, we would begin to see, as Reddy saw, eggs developing and hatching into maggots in jar B. Rather, the first jar here. In the first jar, there's maggots coming out. And over time, and if you watched that video hyperlink yesterday, you know what I'm talking about. Oh. Yeah, those maggots actually turn into flies. Those maggots undergo metamorphosis, and so the flies come from those maggots, which came from the fly eggs, which came from the flies, not the meat. Now, how could we prove that? Well, as Reddy proved it, we look at the second jar here. The second jar, nothing is happening to the meat except for the fact that it's decomposing. But on the cloth on the top, you would be able to watch those eggs hatching, turning into maggots, and those maggots turning into kind of weak little flies because the maggots didn't have the opportunity to chow down on the meat. But nonetheless, the flies came from the maggots, which came from the flies, not the meat. And the third jar here, well, nothing happened. The fly wasn't attracted to it. There was no odor. There were no eggs. There were no maggots. And so Francesco Reddy made this very astute observation himself and was able to disprove the theory of spontaneous generation with this famous experiment of his. And so he showed that living things do not come from non-living matter, but rather they come from living things. I'll go back and give you another moment to write that down. Francesco Reddy showed that living things do not come from non-living matter, but rather living things come from other living things. Flies come from flies, not from dead meat. Flies come from flies, not rocks. Flies come from flies, not a trash pile. Flies come from flies, not mud in a pond. So this is what Francesco Reddy proved back in the 1600s. Very famous experiment. And so we're going to go on now to discuss the 6 basic needs of all living things. And again, we're talking about living things here on Earth. Here on Earth, there are 6 basic needs that all living things require in order to survive. Number 1, all living things need energy. They all need a source of energy. Now, I say the primary source of energy is the sun, because by and large, most organisms on planet Earth anyway, rely on energy from the sun in order to produce the food that we consume and all the good stuff that goes along with it. But even here on Earth, not all living things depend solely on sun energy. About 50 years ago or so, we sent really cool designed submarines to the bottom of the ocean. And they found what are called hydrothermal vents. Now, in the bottom of the ocean, sunlight can't reach to the very bottom of the ocean. And so it's extremely dark. It is pitch black at the bottom of the ocean. And it's also extremely cold. It's about 2 degrees Celsius at the bottom of the ocean. Really, really cold. But there are living things at the bottom of the ocean. Well, how is this possible if it's so cold and dark? Well, these hydrothermal vents release energy from the earth. This energy is hydrothermal energy. The heat from inside the earth is released in these little vents. And the energy that is released also has various chemicals that are released, and entire little ecosystems survive at the bottom of the ocean on Earth. Remember yesterday we mentioned Saturn's moon Enceladus with that liquid ocean across the entire sphere, but under ice? Well, what if there were hydrothermal vents at the bottom of those oceans? Maybe living things could exist there. We have already discovered volcanoes on some of the moons, other moons of Saturn and the moons of Jupiter. There is energy that exists even in the outer solar system where the sun doesn't shine that brightly. So is it possible there might be living things far, far away from Earth? It's possible. Only time will tell. All right, in addition to energy, all living things need food. Food, chemical nutrients. We mentioned yesterday how all living things undergo ingestion. Ingestion, the taking in of food. I love to eat certain things, ice cream and chocolate, for instance. And whenever you eat something, hopefully something healthier than just ice cream and chocolate, but when you eat something, you are ingesting nutrients in chemical form, which is why your body and the body of microorganisms have to digest that food in order to extract the nutrients. Nutrients are required of all living things. So, basic need of living thing, we need food. Number three, all living things need water. Now, as far as we are aware, here on Earth, all living things need liquid water in order to survive. We have recently discovered that near the south pole of the moon, there are deposits of frozen water. We have known for a while now that on Mars, there is solid water, frozen water, ice that exists on Mars. And we know that in the past, at some point, it must have been liquid. We know that in the outer solar system, there is solid water, to be sure, and there's also liquid water. There are some places in the solar system where there are volcanoes actually spewing out liquid water, believe it or not. But as far as a basic need of living thing is concerned, our understanding of life requires that liquid water exist so that the chemical activities of digestion, respiration, all that metabolism stuff requires liquid water in order for these things to happen. So, number three, water, basic need of living things. Number four, oxygen. Obviously, we as human beings, as mammals, we know that we require oxygen in order to live. We take in the oxygen from the air, and we use it to help us metabolize, and then we exhale carbon dioxide. But all living things need a certain amount of oxygen. Even plants that take in carbon dioxide and release oxygen as a waste gas, they also need a certain amount of oxygen as well. Fish, they don't breathe air like we do, but they take in the dissolved oxygen in the water with their gills, and they require oxygen also. So oxygen is a basic need of living things. So far we've got 4: energy, food, water, and oxygen. Next, living space. All living things require a certain amount of space in order to survive. Here in our rural township, especially this time of year, we see lots of dead deer on the side of the road. Why is that? Well, it's because they're crossing the road. Why? But why did the deer cross the road? Chances are they were trying to find more habitat or living space, and the roads are bisecting or dividing up their living space. So they're just going from one living space to another, and if a car happens to be there at the wrong time in the wrong place, well, they get hit. And then they become wolf food up at the Lakota Wolf Preserve. But the point is, all living things require living space. You don't see too many dead worms on the side of the road being hit by traffic, because the living space for the worms in all of the farm fields around here is enough for them to survive without having to cross the road to get to more living space, for example. But imagine all of us students together in one tiny little closet for an extended period of time. I think not only would we drive each other nuts, but we would start ending some of our classmates' lives, because there just isn't enough space to live in a tiny area like that. All right, moving right along. Number 6, temperature. Living things require a rather limited range of temperatures in order to survive. We humans have a very narrow range of temperatures that we can survive in. We certainly can't survive in temperatures beyond the temperatures that liquid water can exist. We can't exist for a long period of time where all water is frozen ice, especially if we didn't have jacket or a source of heat to warm us up. We would freeze to death. Read the famous Jack London novel, To Build a Fire, and you'll know about what happens to the human body if it's too cold for too long a period of time and you're not dressed appropriately. Likewise, we could not exist in temperatures where water is existing in the vapor form as steam. Our bodies would be cooked literally in temperatures that high. So our lives are limited to a limited temperature range during which liquid water can exist. Other species have slightly different greater or lesser tolerations of different temperatures. But nonetheless, as far as we know, here on planet Earth, all living things require a certain temperature in order to survive. There are limits. So these are the basic needs of all living things. Now, tomorrow we are going to be doing a very exciting lab activity where we are going to be testing for living things. I'll save the rest of the details for tomorrow. I think you will find it rather interesting. So until tomorrow, I'm going to say bye-bye.